Hey, good afternoon, everybody. Can you hear me? This is so cool. My name is Mordecai Rosen. I am the Vice President of Product Management for CA's Privileged Access Management business. I'm a relative newcomer to CA. I came in about 3 months ago with an acquisition of a company called Exedium, which was a pure play in the privileged access management space. How many people in here, is this their first CA world? Okay, me too. This is my first CA world. And I am overwhelmed and excited, but mostly really kind of proud to be part of the security business unit and representing our security strategy and our products. I will also be joined during the session by a colleague and a good friend of mine, Jeremiah Cornelius from VMware. Jeremiah is a security architect, evangelist extraordinaire. We have known each other for what's pushing about 3 years now, and he's an expert in virtualization, he's an expert in security, and he's going to wind up giving us VMware's view of the topic we have picked today. Awesome. Okay, so this presentation is going to be chock full of goodies. It's thematic in nature, so we're going to be talking about the security in the software-defined data center. There's a rather large product announcement for us, which is an announcement of a new release of my product. We have VMware up on stage with us, and we also have a customer/partner testimonial. So it's going to be a multimedia extravaganza. The theme of our talk today is really about how do we secure the modern data center given, one, the current threat landscape, and two, our need to transition to the application economy and probably accelerate the requirement to transition to the application economy. Traditionally, it was the job of security vendors like ourselves to provide you with tools and platforms and tools to allow you to secure your data centers. But times have changed and changed profoundly, and it's given the current threat landscape, it's time we have to rethink our approach to security and involve more people in the ecosystem to help us secure our data centers because the threat landscape is significant and serious. And one of those key players in the security ecosystem is the data center infrastructure providers. And we have to wind up moving to a point where the data center infrastructure beneath us provides us with a level of security, integrates identity and manageability into the fabric to allow you to secure your data centers and allow us to build our next generation products to help you do that thing. So that is the theme of our little fireside chat here today. I'm going to spend the first 10 minutes, 5 to 10 minutes, trying to frame the issue. Then I'm going to bring Jeremiah up to talk about VMware's view of the software-defined data center and to overview for you a groundbreaking technology, which is their software-defined networking technology called VMware NSX. And then I'm going to pop back up here and make an announcement of a new release of CA's Privileged Access Manager that has a significant set of extensions to support VMware NSX. So I think you've heard for most of the morning people characterize the threat landscape that we're living in, and I thought I'd take my opportunity to do that as well. And I'm going to start out by saying, for the last 25 years, I think we've done an amazingly good job developing security technology to protect our perimeter. We have defense in depth, we have layer after layer, we have firewalls and IDS, IPS, and network AV, we have web proxies. But the reality of our situation today is that we've been breached, and you can pick whatever metrics you like. FireEye says global breach rate is 93% for global enterprises. KPMG verifies, Cisco says it's higher than 93%. But whichever metric you pick, it's significant and it's bad. And we've also kind of come to learn, and this is an observation, that identity, and we've kind of heard it all morning, has clearly become an Achilles heel for us. It's a new threat vector. And picking up from where Steve and Nick left off this morning, there is a 95% success rate on spear phishing after 5 to 6 attempts. Our network administrators and domain administrators who hold the keys to the kingdom post their resumes on LinkedIn and Facebook. I kind of remember right after the Cisco Sinful Knock breach came out, I went to LinkedIn just to see if I typed in a search for network admin, what that would actually look like. And I got 43,000 hits. So that combination is bad, and it's manifested itself in some significant breaches, including the Target breach, the Cisco Sinful Knock breach as well. And once our perimeter has been breached, I think one thing we've come to learn is that the controls inside our data centers, the security controls, are much less stringent than the perimeter that we've set up. So lateral motion inside of our data centers after the breach is less of an issue. And this is what leads us to, I think, a phrase we've all come to learn over the last 5 years, maybe don't love that much anymore, which is this is all the sequence of the breach kill chain, which is a term that Lockheed Martin coined and defined a 7-stage process. But in my mind, that process really winds up being gain access, elevate privilege, and then wreak whatever sort of havoc you're going to wreak. And that is the process we've seen. If it's not walking through the front door of an open 0-day vulnerability, it is the breach of or compromise of a privileged credential to take advantage of the rest of the kill chain. And once an active malware network has been set up in an enterprise, what's amazing is the gestation period. So the duration of time from breach to discovery, and I think it's sort of pulled back a little bit, but it's effectively 8 to 9 months. It's so long that there's a new cottage industry evolving called cybercrime as a service, where a perpetrator breaches and then sells access to that breach. So to dig a little deeper, the perimeter has certainly failed us all, but it hasn't failed us in what it was designed to do. It was never designed to support the sort of business that we moved forward aggressively over the last 10 years to build. Because after we built our perfect perimeter, necessarily we wound up connecting our business to our vertical. We did vertical integration, we connected it to our supply chain, we let our customers in, we let our partners in, we let our service providers in. And the management of the perimeter wound up being compromised and significantly compromised. So now we wound up with the best security controls we could devise, and we're the ones that let everybody in and buying more perimeter security products. Once you've sort of adopted this mentality, it doesn't help the cause. So once we've determined that our perimeter was breached and everybody was inside, we wanted to take the next step, and that next step was network segmentation. It's manifested itself in all the compliance standards. Some way to draw a smaller perimeter around something that we could protect. And the way we went around doing that is we took our perimeter technology and we tried to deploy it internally in our data centers, deploying hundreds of firewalls throughout our data center. That wound up being a square peg for a round hole because, one, the original external firewalls weren't manageable once we were poking holes in them. Now having hundreds of firewalls attempting to secure various network segments and keep those policies synchronized was just kind of walking down the wrong path. The east-west firewall dilemma. So we find ourselves in this position that we sort of have to reinvent our data center infrastructure and reinvent our approach to security. And it's not just the security vendors. And the security vendors like CA will clearly start providing you with the next generation of security technology. But the data center infrastructure providers have to reinvent the underlying platform for us And that reinvention has to allow us to do micro-segmentation, create micro-perimeters to actually wind up protecting the application cluster that they're actually running in our data center. It has to have identity built into the fabric, and it ultimately has to be manageable and manageable at scale, and manageable at scale really means automation. It has to support policy-based automation. Humans will continue to manage, but to support the sort of security access policy we need in our next generation data centers, we need that level of automation, and that is the next generation of the software-defined data center. As you all know, VMware is a thought leader in the space. They've created a set of technology 2 years ago and launched their network virtualization and security platform. It is a groundbreaking piece of software that attempts to meet the requirements that we're sort of describing here. So let me yield the stage to my good friend Jeremiah Cornelius to talk about VMware's view of the software-defined data center.
Thank you, Mo. Great. Fantastic. Thank you so much, Mo. You really actually tell so much of the story so well. There's a lot of it I probably don't have to go into because he's really laid out at least what sort of the background is here. One of the things that I'd like to reiterate that Mo was talking about is really what has happened and what has changed with the data center itself, how it's used. We do have some of the best controls that have ever been in existence. And we continue, if you go to any of the security shows and you follow the press, we continue to devise better controls. But there really is a continuing problem with the loss of data out of data centers and the inability to regularly secure workload as we're using it today, let alone with the degree of dynamism, with the kind of things like bringing in DevOps situations, or simply being able to provision on demand according to business need, as it is today. And that's because there's really a fundamental misalignment, ultimately, with how controls have been deployed and how we are capable of managing them, because they're tied ultimately really to some form of physical topology. Even if it isn't a perimeter-based, it's generally based on aggregation points inside of a network, or they're based in agents that have very little idea about the connected environment that they have to face. So that's what we end up calling really the context versus isolation problem. We'll talk a little more about that. So we can't have our controls in the traditional data center everywhere we want them to. It's operationally infeasible to continue to maintain rules on perimeter firewalls in the hierarchical sense. They're really subject to the most extreme forms of change management, and nobody, once a firewall rule goes in, nobody wants to change it. And inherently building to these physical aggregation points and building physical firewalls ends up inherently limiting what you can do with that software-defined data center that you virtualize so much. Things like being able to motion workload to where it's most agile or where it has the most resource in order to meet demand, to duplicate it. All of those things are restricted because you're really tied to physical topology still in a lot of ways. And provisioning is dramatically held back when you can provision a new workload in a matter of minutes, but you still have the same provisioning method for your firewalls that you had back when you were bringing in a new ProLiant or what have you and plugging that into its own space in the rack. Virtual firewalls seem like a pretty good idea, but all they're really doing is a repackaging of that same physical firewall, generally then at a greatly reduced level of performance, and still then tying things more or less to locations on networks. You've just mapped that topology into a bunch of wires that are produced by a virtual switch, and you've repackaged the same IP that used to sit on its own Intel processor into a little appliance on the thing. It's still complicated. You again have management sprawl and generally an inability to have rules work at the level of abstraction that you want them to be able to actually make use of this environment that we have, because it's now the basis of the private cloud inside of most companies, what's becoming the hybrid cloud, and we want an underlying technology to be able to build then the clouds that you can migrate to, both off-premise and to have those kinds of contiguous environments where you can move workload at will, where it makes the most sense, both for compliance reasons and for the economics. So that's where NSX comes in. The value proposition of NSX is as a software-defined data center networking layer, so that we can take what we'd already done with storage and compute. We created this great virtualization layer, which most people are using, being able to create virtual machines, but actually not really focusing on the virtual machine, focusing on the application itself. Nobody wants a machine, they want their app, and that's what the business sees, and that's how we package and we deliver. We can bring apps built on one or many more VMs very quickly. The next generation networking model that NSX represents for a software-defined data center does exactly that. We take that virtualization stack, and then we are able to provision it with the core networking capabilities and the basic security capabilities that are necessary in order to be able to deploy that consistently with the whole application. My application needs to go out. I'm used to bundling 2 or 3 VMs together. Why don't we contain with that all the necessary switching, routing, ACLing, potential baseline load balancing, and the firewalling, so that we can actually end up defining some logical boundary around this application that then becomes the basis for all of the other additional security controls that move beyond just simple access control and creating whitelisting for what traffic should be on there. We want the high throughput rates, we want the east-west firewalling, and the native platform capability, and the way we do this is not by packaging this in a VM, but by locating it inside the hypervisor itself, running at kernel speed. We scale out with the virtualization layer, and then on top of that, we actually end up improving throughput the larger we make our clusters, distributing this further. We have an entire network hypervisor now, represented by NSX and these components inside the kernel, that produces virtual networks that don't just respond like in an SDN fashion to changes in the application. The networks themselves are an attribute of the application itself. So they bring policy with it to begin with. A network doesn't exist in any other terms except for the expression of a connection policy related to an application or a virtual machine. And that's a very interesting difference. Then we have our virtual networks, we have our containers, and these are at a high enough level of abstraction we can make rules between them that aren't brittle, they aren't hierarchical, they can be adaptive and dynamic, and they can respond to conditions either that happen within the VMs and applications, or again with the authenticated roles, which is something we'll go on a little bit later. So you want to deliver an inherently secure infrastructure, at least inherently securable, where security is a fundamental product of the state of the network and how it is built in itself. It's not bolted on, it's not an intervening technology, it's not injected in band into the packets, it's managed out of band on a separate entire control plane and outside the attack surface of any of those virtual machines itself or the applications that run on those. Within the data center perimeter, then we essentially have the ability to put a firewall on every NIC and to manage them at a very high level because you're treating them just like you're treating the rest of the application. The VM can be its own DMZ. If that DMZ is compromised, that DMZ isn't shared with any of the other VMs. You don't have a zone. You have as many DMZs, so to speak, as VMs that actually need to listen on your perimeter. So the compromise of one machine doesn't become a hop point to continue to do so. And penetration testers themselves will tell you the #1 way that they get stopped in their tracks and end up having to move on is when they run into very heavy perimeter-based segmentation, let alone what happens in the deeper layers of the network. We still maintain our perimeter controls. They're our best first line of defense. But we can also then build a set of interior controls that are no longer tied to the static properties at the edge of that perimeter. We can respond to the business, we can do so at a lower cost, and we can be extremely agile so that when they say we need a new application inside of 6 weeks, you can have that new application inside of 6 weeks. You don't have to wait another 10 weeks of provisioning cycle, ensuring that you have capacity and hardware, and then go through the entire loop of communications to make sure that things get reviewed, because you're stamping out from templates that have been agreed upon in advance. Your security policy is dramatically simplified because you are relating to the business relationships and the entities between applications and their users, rather than proxying these things down to micromanaging IP addresses, ports, and protocols. You're operating at a much higher level of abstraction in order to put these policies in place, and therefore you also have a defined boundary to attach additional controls, whether that's network filtering controls to ensure that the allowed traffic actually is safe, or that you have identity controls that can adapt and modify to the changing conditions of these various microsegments. You have logical grouping enabled, and then you also again contain these threats as we talked about. When I talk about intelligent grouping, this is really great because they are containers and they aren't hierarchical. That means an object could also belong to many different groups. Maybe it belongs to a group of web servers, but it also belongs to a group where you also manage a certain patch level of a specific Linux revision. They can be managed and operated separately, and there's a combined policy there. So it doesn't work like OUs in an LDAP. It then becomes very flexible because you can attach them to operating systems, machine names, the types of services that are run. Again, modeling your application tiers as you do in the world today, which is a great migration path. Also then, of course, regulatory requirements. So you can have PCI zones and that all set up in such a way. And they're not also exclusive then of these other types of grouping. So you actually have an audit perimeter and you have a place to locate your other controls for operating PCI. You also then again, security posture. And this is a very interesting dynamic one, because you can then do things like test for a condition whether machines, say, are vulnerable to the Heartbleed vulnerability. Those that test for that can have a tag put on the virtual machine, and that virtual machine will then be put in the Heartbleed group along with the other grouping that it already belongs to. You can filter for the Heartbleed vulnerability then on the perimeter of that group, but in an efficient way so that you're not burning these cycles on your virtual infrastructure for every single machine, some of which may not even, the vulnerability may not even be a possibility. You get to scale out very easily, and now you have a place to remediate, and also then, of course, to manage and understand what your effectiveness is in terms of remediation over time. So it's very interesting and powerful technology. We don't have the ability to go in a great deal of technical depth about it, but I think outlining at least enough of the background of what we're trying to do with software-defined networks, having security as a fundamental principle at the basis of them, so you can understand where some of the work that we've done in order to add an authentication, authorization, and privilege role access with X Suite plugs in, and the value that it can provide to an infrastructure like this. So NSX, we commonly describe it as being in the Goldilocks zone of security. Again, the Goldilocks zone got used by NASA to talk about where you find habitable planets at a certain distance from the sun. I think obviously then, very clearly that refers again to the metaphor of not too hot, not too cold, just right Goldilocks. Everybody can understand this right off. This is what we're trying to do. We are trying to be in that space between what I talked about with isolation, where you get in aggregation points and perimeters, and being able to create a high degree of confidence of creating segmentation, balanced with context, understanding who your user is, who should be running an application, what that application does, where it should connect to, and the properties also of the applications or the other services that those things connect to as well, informing both of those things and bringing them together with a ubiquitous layer which can be provided by the hypervisor because it's present under every aspect as software below the virtual machine, below the application, below the user authentication, and now ultimately below all of the networking and security capabilities that are needed to be able to provision that workload. We can't do this entirely by ourselves. As I say, we do something very simple with access control and what's really whitelisting and creating defined segments, microsegments, that can be a shared perimeter. So this ecosystem of distributed services like provided by X Suite allow us then to use this shared boundary to create complex policies that are very simple to manage, so that you manage, say, all of the PCI aspects about a workload with 4 or 5 different controls together as a unit by attaching policies to those kinds of groups. You have a lightweight level of integration that allows you to orchestrate multiple controls together, again, at the level that you want to provision an application, rather than micromanage what type of control exists and where it's located. So VMware is partnered now with Exedium, all the way up into and including the time now with the CA acquisition around X Suite and integration for authorization, privilege, access management that is aware of these types of boundaries. And I had the real privilege of working with architects at Exedium. I really call out Ryan Maple because he was fantastic in working with me, where I could define some high-level use cases, and he spent a good deal of time and incredible engineering expertise in turning those use cases into something real and valuable. So Mo's going to come up and talk then now about what those use cases are and how they're being delivered today with today's announcement. Mo?
Hey, thank you, Jeremiah. So let me start out by announcing our first release of CA Privileged Access Manager, formerly known as Exedium X Suite. It is the release that we've been working with VMware for some time, and it has full extension and coverage for privilege access, managing both privilege access to the VMware NSX management plane and privilege access to all VMs running in the software-defined data center model. Just to sort of back up for a second and describe what CA Privilege Access Manager is, it is a comprehensive privilege access management system for the hybrid enterprise. It has a back-end system that does full lifecycle credentials management, and then winds up with a front-end system controlling roles-based access, full session recording, full user attribution with federated single sign-on to targets. And the product itself was designed to be a single platform to manage privilege access to the entire hybrid enterprise, from mainframe to rack and stack, to virtualized data centers, to infrastructure as a service, to SaaS applications. And the area we're focusing on in this talk is specifically the extensions as it relates to VMware NSX and how we have extended the capability of the product to leverage these underlying security capabilities introduced by NSX to provide a solution that's really unique, I think. So let me walk you through a few use cases. So one use case is the east-west firewall case, which is we want to support privilege access throughout an entire software-defined data center, and we want to leverage east-west firewalls to maximize security. So what the extension we added to Privilege Access Manager to do that thing is we can now run in a deny-all environment for all privilege access. And we can dynamically, on the fly, at time of privileged user access to a target, at the time of the request, we will use the interfaces provided by NSX to modify the distributed firewall rules on the fly to provide access for that period of time. And when the privilege session ends, we reset to deny all. So now this product running on top of VMware NSX allows us to establish a deny all network for all privilege access, which really helps mitigate the risk of privileged user compromise. Another use case, and this is always the case as you're integrating with multiple policy regimes, is that we tightly integrated with NSX's grouping and tagging policy. And what this allows us to do, Jeremiah described a third-party application running within NSX, searching for PCI or PII data, can tag a set of VMs and put them in a PCI enclave. We will recognize that tag and that regrouping, that dynamic regrouping in real time, and the privilege access policy to that set of targets will change as the VMware NSX group changes. So to the extent that a VM was tagged as having PCI data and got put into a PCI enclave, and privilege access to that is a different set of people who would have originally had privilege access to it, those set of access controls are deployed on the fly dynamically. And to even extend that, it allows Privilege Access Manager to sort of coordinate security with other products and now dynamically react to threat events going on in the infrastructure. So I'll move away from the PCI case and say a third-party polymorphic threat detection engine is running in VMware. It detects that a VM has been compromised. That engine will tag that VM as compromised. NSX will build a quarantine network around it, so it will surround it, cutting off access from most of the rest of the network. And when that happens, because of our integration, if there are a set of privileged user sessions associated live with that target at that moment, we can employ on-the-fly controls like force reauthentication of every privileged user who's accessing that target VM. We can turn session recording on when there was no session recording or auditing turned on previously in the policy, or we can terminate all those sessions. We can do that on the fly as we sort of dynamically synchronize with the tagging structure of NSX. And finally, the last use case is in the software-defined data center, as it is in cloud. Management, privilege actors are not only human beings, they are scripts, they are software. We know that management of cloud and software-defined data centers mostly done by automated scripts. And so if you don't protect privilege access to the APIs, you don't protect privilege access. So CA Privilege Access Manager, this release, protects and proxies all API access to VMware NSX. It does full lifecycle credential rotation and winds up protecting and fully auditing the API management plane to provide the sort of 360 degree of protection for privilege use. So this is what the release looks like, kind of all on one slide. It has full credentials management, it's federated SSO, it has a broad range of authentication schemes, it does full session recording and auditing, and full end user attribution with the dynamic extensions that I just mentioned for VMware NSX. And we thought it might be valuable for you to see a customer partner of ours and what their reaction was to using this technology over the course of the last few months.
Hello, my name is Scott Ormston, the Director of Solution Architecture at Apogee, a federal reseller and system integrator. The federal government has an urgent and critical need to secure privileged user access to virtualized resources. The Federal Information Security Act of 2014 made it clear that agencies must address a number of critical security areas. As a result of this, and to help federal agencies respond to a series of new mandates and demands, I started researching ways to secure high-value systems and applications. As our clients continue to realize the benefits of virtualization, they are particularly interested in securing access to the systems built on VMware as the preeminent virtualization solution deployed within the federal government. There's a considerable gap in cybersecurity between what is mandated and what government agencies currently have in place. Privilege accounts, in particular, seem to still be manually managed and often shared among multiple users, while strict authentication and accountability for these types of accounts are being required. My team went to work to evaluate how to help our customers, and we determined that CA Technologies' Privileged Access Management, or PAM, is a key tool to provide protection against both internal and external threats, and it provides much of the functionality needed to meet several federal requirements, including 7 of the 11 FISMA categories, and specific White House cybersecurity priorities. Having our previous experience and knowledge of the PAM solution, we turned to CA as a trusted partner, and they informed us of the upcoming integration with VMware NSX that could assist in meeting the challenge of securing user access, especially privileged user access, in our customers' VMware environments. CA provided us with early access to the latest release of PAM that seamlessly integrates with VMware's NSX. By leveraging NSX's distributed firewall and dynamic tagging and grouping capabilities, PAM allows us to automate access to and monitor all privileged user connections. We tested this in a lab environment and found that we can dynamically assign PAM user session controls simply by tagging virtualized resources or assigning them to the appropriate NSX groups. The solution works well because PAM directly integrates at the API level with the NSX product. Once the controls are applied to the session policy, they are then leveraged to build dynamic distributed firewall rules to allow access only when specifically needed and when the privileged user's identity and credentials have been validated. Introducing PAM into this VMware environment allowed for expanded security for these accounts while not complicating privileged user access or deployment requirements. We feel this set of capabilities will help our government customers further secure access to their data by monitoring and controlling privileged user access to their critical virtualized resources. Affigent sees our ability to deliver this integrated solution as a differentiator in the federal cybersecurity marketplace.
Thank you, Scott Ormston. Let me sum up. We're kind of coming to the close of our session today. I think here are the conclusions and observations that we have, that it's clear that we've been breached, our existing security layers have been breached, that next generation software-defined data center infrastructure, like VMware NSX, is inherently more secure than the infrastructure we're running today, that protecting the management plane of the hybrid enterprise is required to break the kill chain and to deflect the primary compromise for most high-profile breaches you've read about today. And I kind of make one last comment, which is, I think for the longest time, security has been viewed as a tax. You know, it's a cost, and the security group has kind of always been mostly carved out of operations. I think we've moved to the place where we have to flip that on its head. Security is really a business enabler now. And if we sort of view security as a business enabler, we can wind up creating platforms and next generation products and leveraging those products so that we can more aggressively move to the application economy. That is the end of our talk here today. I want to thank you for your time. It is greatly appreciated. We have other sessions talking about this product and tech talks and general reviews. Please go see them. There are demo stations all around. If you want to see the product live, please go do so. You can have one-on-one conversations with our architects and engineers at the Smart Bar, which isn't what I thought it was. They don't serve any alcohol at the Smart Bar at all, but you can have a good tech talk with our engineers. And I think we've reserved just about 5 minutes for any Q&A, if you have it.
Yeah, we got time for a little bit of that. Am I on live too? Do we have any questions?
I think we're online. Do we have any questions? Thank you very much for your time. We appreciate it.